the problem is topic number 6, and then please write down the name for the coming Saturday. You can start when you're ready.
Hello everyone, I'm 李佳静. From Today I'm going to report a problem C, GMP faucet. And here is a problem statement. A leaky faucet develops interesting GMP pattern, where the time between drop depends on the water flow rate. Investigate this phenomenon and study how it depends on relevant parameter. And here is our main fault. The first point is the relation between water flow rate and time interval between droplet. And second point is analyze the forces on water droplet at a different water flow rate. So here is experiment setup. We use a faucet connect a tank and use a mixture cylinder to calculate the water flow rate. And here is an observation. We see a low water flow rate to a high water flow rate, and we find the three stages. The first stage is periodic doubles. The periodic double have two droplets. The first droplet is the primary droplet, and second droplet is secondary droplet. And when we increase the water flow rate to the 0.8, we can get the cat. Cat is very sensitive initial condition and doesn't to predict. So when we increase water flow rate to a 1.3, the water will become a liquid column. And here is net balance. Well, assumption is only for primary droplet that isn't affected by vibration, and the force from cementation compared with a gravitational force. We call a liquid column radius is R. So when gravitational force is equal to the cementation plus the viscosity force, the droplet will not fall. And if the gravitational force is greater than the cementation plus the viscous force, the droplet will fall. And here is a vibration. Where droplet form and drop, the residue water will have a vibration like this. So we can get a formula to describe the vibration. This is gravitational force, cementation, and the viscosity force. So gravitational force reduce the cementation and viscous force, we can get the vibration. So here is vibration at different water flow rate. We call the vibration time is T1, and the vibration the time interval is a T2. If the vibration time is less than the time interval, the primary droplet will not affect by vibration and very stable, like this. And if the vibration time is greater than the time interval, the primary droplet will affect by the vibration, like this. So when vibration time is much greater than the time interval, the droplet will have the cavity. And here is a plateau radiusability. When the water drop, will elongate a liquid column, and the liquid column tends to minimize surface air, so the liquid column can have a fluctuation, and the liquid column and shrink into a droplet. So we call a liquid column length is L. We call a liquid column diameter is R. If L divided by R is greater than the pi, the liquid column will have a fluctuation and will have the plateau radiusability. And here is the time interval. The x-axis is water flow rate, and the y-axis is time interval. So we see the left side is the periodic droplet. The right side is the chaotic condition. So we see this. We can know in the periodic condition have a two time interval. The larger time interval is primary droplet, and the smaller time interval is secondary droplet. And when we increase the water flow rate, we can see the time interval will decrease because the water will accumulate more, so time interval will decrease. And because when time interval decrease, the vibration effect will increase. So the range of the time interval will increase. And in a chaotic condition, because vibration time interval is much greater than time interval, so the range of the chaotic time interval will increase. And here is time interval of chaos. Because not only the water flow rate will affect the time interval, and some air resistance vibration will affect the time interval, so we do a test experiment. In periodic doubles, we can see the time experiment is very similar. And we do the chaotic conditions experiment test. We find the result is very different. So we say that this is chaotic condition and this is periodic double. And here is droplet mass. You see, when the water flow rate increase, the amount of accumulation increase over time, so mass will increase. And see, in a chaotic condition, when the water flow rate increase, the range of mass will increase. And it's because about the vibration direction. Because the vibration size will change and vibration direction also will change. Like this, if a vibration direction is outward, the mass need to increase to break the net mass. And if the vibration direction is downward, the mass will decrease. So when the water flow rate increase, the mass will increase. And here is vibration formula is about the mass and the vibration. We can know in the when in a periodic condition, when the mass increase, the vibration will increase. And in a chaotic condition, because have a different mass, so have different vibration. Here is liquid column well-length. The water flow rate increase, the mass will increase. The mass will elongate a liquid column, so when the mass increase, the liquid column will increase. And liquid column increase will cause the plateau rating instability. And we can see in the chaotic condition, this about the chaotic conditions, liquid column, the x-axis is timeable, the y-axis is liquid column well-length. And so we have two factors to affect this liquid column. See the left side is because the plateau rating is ability, because the turbulent flow in the below. So when the time interval increase, the liquid column will decrease. And the test factor is the different mass. If I have a different mass, we'll elongate a different liquid column. And so we can know the chaotic condition where water flow rate increase, the range of the liquid column well-length will increase. And here is the amplitude. We can see in a slower water flow rate, the amplitude only have the one. And when we increase the water flow rate, can see the amplitude have a different. And it's because the vibration can supply impulse. The vibration, if the vibration is downward, and net vibration also is downward, the vibration need to apply the next vibration. As vibration is downward, the next vibration is outward, the vibration need to reduce the next vibration. So vibration have very different. So when the water flow rate increase, the range of vibration and the amplitude will increase. And here is the experiment about outlet diameter. So we do this variable is outlet diameter. We see when outlet diameter increase, the time interval will increase. We see have the two factors to affect this time interval. The first, because we control the cell water flow rate. So when the outlet diameter decrease, the water velocity will increase. So the viscous force will increase. So the time interval will stable. And here, because the outlet diameter increase, the contact air and surface air will increase, so mass will increase. So the droplet need more time to accumulate, so time interval will increase. And here is about result. So we use a checker to see where outlet diameter increase, the contact air and subtension increase, so mass will increase. And because the mass increase, the mass will elongate the liquid column, so the liquid column length will increase. And here is we observe that when the smaller outlet diameter only have the single periodic. I think that it's because outlet diameter decrease, the viscous force increase. So water is more stable, so only have the single periodic. And just this also have the double periodic. It's because when the droplet fall, a lot of the residual water is remain, so the net droplet will fall quickly. So here is the conclusion. We have a three stage. The first is periodic double, and when the liquid critical value is 0.8, And increased water flow rate can see the water will cast, and in the critical value is 1.3, the water is become the liquid column. And in a periodic double, we have two droplets. The first droplet is the primary droplet, and second droplet is the secondary droplet. And this is a vibration formula. This is gravitational force, surface tension, and the viscous force. So with the gravitational force reduce the surface tension and the viscous force, we can get a vibration. So we do two variables. The first is different water flow rate. The second is different outlet diameter. When we do the different water flow rate, when the water flow rate increase, because the water accumulate will more over time, so time interval will decrease. And when time interval decrease, the mass and liquid column will increase. So the mass increase, which is this formula, the mass increase, the vibration will increase. And also time interval decrease, so vibration effect will increase. So can cause the chaotic. And in the outlet diameter, we can see when outlet diameter increase, the time interval will increase. It's because the outlet diameter increase, the surface tension and the condense air increase, so the time interval will increase, and the mass and liquid column will increase. And because outlet diameter increase, the velocity will decrease, so viscosity force will decrease. So we can know about outlet diameter increase, the water droplet are more stability. So thank you for your attention.
Thank you for your presentation. So time for the opponent. 2 minutes.
Please turn to the page that you mentioned the conclusion. Yeah. So you change the velocity so that you can observe the three kinds of space.
We change the water flow rate.
But what about
The one here. You can use.
this one? This one.
This is the water flow rate. Yes.
So okay, you change your water flow rate so that you can have the data with the formula.
Yes.
Okay, thank you. And please turn to page 5.
Thank you.
Can you mention about, because there are several forces in the droplet, so can you mention how many forces are there and what kind of forces are there?
Here have three forces, is the gravitational and the surface tension and viscous force. Yes.
This force, so this is, yeah, surface tension force, like gravity force and
The surface tension.
surface tension force.
And
So,
viscous force.
and is there any direction in your picture? Because I'm curious about the direction of the force.
You mean is vibration?
Oh no, direction. Direction of the force. Okay, we'll talk about later. And
And I think the gravitational is now, and the surface tension and viscosity is our.
okay. And please turn to 16.
Well, very good question. Time's up. So 3 minutes for preparation.
define the opponent from variable 2. And now I'll start my presentation. The problem statement that the reporter focused on the relationship between water flow rate and time interval. And she analyzed the forces under different flow rates, which I think is very clear. And her theory is about the net balance, vibration, comparison of droplet time interval and vibration time, and liquid column rate of length, and the different phases, which is periodic, doubles, chaos, and liquid column. The experiment, she have a variety of the data, but I think she is take out some chart to have a sum up, because I'm a little bit confused about a lot of decrease, increase, so I think I will discuss with her later. But although despite the things above, I think her presentation represents that she has do the experiment very well. And here's the pros of the reporter. She has a pure correlation between theory and experiment, but she has unclear explanation, which makes me confused, and unclear graphs. So I think she will explain to me later, and not enough data, because the data is on the chart. So and the audience below can see it very clearly, and not persuasive because there's no theory to support the experiment. I think it might be some observation, because the theory might not be very full to explain those things. And controlling of initial conditions, I think I will ask her about this. And organize content of the speech better. I think it's just like what I say. You have to like have a chart or something to sum up your summary. And I think their discussion will discuss this. And here are some points: the flow rate, radius of the faucet, and water pressure, and stable water flow rate. And I'll ask her, how does she think about what will cause the error in her report? And yeah, just like what I say, I think I will discuss with her about the point here. Thank you. And I will invite the reporter to go up and I'll discuss. Did you compare three phases in your experiment? Or do you make a chart to represent the three kinds of phase? Because there are periodic phase and chaos phase and another one. So did you compare three kinds of phase in your experiment?
Three condition?
No. Okay, so skip to the next question. How did you think that is a reason to cause a chaos?
I think it's because the very sensitive initial condition and have very much thinking, because the gas and the water flow rate or the vibration and air system pressure also can cause the gas.
Did you consider temperature?
Yes, we do one day do also we have control the temperature.
How did you control the temperature?
Then we do the experiment one day, and we have to use the to measure. Yes.
But here's a question. Although you use like air condition, the air temperature might not be constant in the whole room.
You said the air conditioner stand?
No. Although you use the air condition to control temperature, there might be some where it's not. Although you use the air condition, the temperature in the room won't be the same. Yeah.
Because I do the area experiment one day and I see temperature, we try my best.
No. I think that although you are in the air conditioned room,
we fit it in the temperature sensor.
Okay, on that one. And thanks for your explanation, and please turn to page 9. Can I see any boundary of the phrase in this chart?
Boundary, because we critical value is to, because we to use a video about we use a tank and open the water faucet and this water level will down and use this to check the critical value. But because the video is so long, so we only check the sound. Yes.
So this is the whole experiment data.
No, it's because the video is so long, so we needed to check all video, but we have to
So
do
the
some.
data here is came from the video.
No, I use the water level down to measure critical value.
Yes.
So we use this is to measure to use a very big tank to see in the same water flow rate to see a different time interval.
So different time interval will cause the three kind of different states. Is that right?
Can you give this?
Because there are different time interval.
Yes.
So in the different time interval, it will cause three kind of different states.
Yes. Yes.
Like the periodic phase, like the KL phase. Yes.
Can you again?
Oh. Phase. Because you control the time interval, so
Yes.
and it will.
No, we control water flow rate and time interval.
So by controlling the flow rate. Oh,
Time interval is our data is not
okay. So by controlling the water flow rate,
Yes.
it will have three kind of different stage.
Yes.
So the three kind of different stage will. Is there any
We can state.
boundary to get Is there any?
We didn't use this chart to explain the we have to measure because you have this data. We change the level of water to measure the critical value about water free stage.
But I think
But
that
because
maybe you can say it.
because the video is so long, so we only check the some data is not all.
But you actually gained all the data from the whole video, but you just do like in the chart you just have one stage or the whole stage is in the chart.
Because
That's chart.
it's not check.
It's not check. Can you go back to the page that we were talking about the different stage? Yeah, this one. Here's a. So you can see here. Here is a periodic.
Yes.
And this is the chaotic time interval.
Yes.
So how did? Okay. That's the next question. Can you draw the force of the flow rate on the blackboard? Because there are several forces, and I want to check the direction.
Not droplet force.
The
Droplet force. The droplet and the first can have long gravitational force and have a viscous force and have a suspension.
So the response force is here, from here to there. Okay, I know. And because here are three different kind of stage, so how do you think the impact of the three force will impact on the different kind of stage
Okay.
and the importance of them?
Okay. And this is very stable and not affected by vibrations condition. And if when we increase a water flow rate, because when a droplet fall, the residue water can have a vibration damage. So if the droplet have affected by vibration, have a less force, is the vibration. And vibration will down and out like is the vibration. Like this. Like this. The vibration will down and also will out.
So this is in the chaotic phase stage.
Yeah.
The question I asked is that there are three different kind of stage, and can you tell me in the three different kind of stages, which force will be the main impact on the
Yes.
flow rate?
Vibration.
Vibration will be the
affect
main force in the
the main force is the vibration of the gas.
oh, so the vibration affect the chaos.
Yes.
Okay, thank you. And do you think we can find any regularity in the chaos stage?
Can you repeat again?
Did you think that we can find the regularity in the chaos stage?
Oh, okay. Regularly in the gas state. Okay. We use the list like if the not gas, a droplet can a circular droplet, a private droplet, a circular droplet, a private droplet, and gas also have like a private droplet, but now the also like this have a like private droplet and this circular droplet, but because the have the vibration effect, so time interval and the mass will affect, so it can become very not to predict.
So, in the chaos phase, is there any damage? Because you can see that the dot on the above there won't is there any limitation in the chaos phase, such as the droplet, the time interval? Okay, I know. Please turn to page 14. Can you describe this? Because I can see that the blue dot is on the top of the chart and the gray dot is here. Can you explain the difference between them and the one here? Because here is 1, 2, and 3, and 4. But here is gray dot. So can you explain more about the chart in the page?
Okay, because it's the free outlet diameter, the orange is the 3.5 and gray is 5.5 and blue is 6.5. It's the free outlet diameter's time interval.
So can you like have some of that the different diameter will affect on the result, just like the one here. Can you talk about again?
Okay, because we control the same water flow rate, so when the outlet diameter increase, the water velocity will increase, so the viscous flow will increase, the water is more stable, so only some have the single reading.
So this means that the outlet diameter decrease
Yes.
and the flow rate velocity will go up and the viscous force will go up.
Yes.
Okay. And how about this?
Okay. Because here in the outlet diameter increase, the contact air will increase, so the surface air increase, the surface tension increase, so the mass increase. The mass increase, the water need to more time to accumulate, so time interval will increase like this.
Okay. So the mass will increase.
Yes, because the surface tension increase. We follow the net mass.
Okay. Turn to 15.
15.
Yeah. The difference between the two charts, because there is a straight and
Very nice discussion, but time's up. 1 minute summary.
and here's the conclusion. We discussed about the temperature control, and I asked about how does she control that, and she said that you use the air conditioner to control the whole room, and she actually used things to, and she said that it will be stable, and I agree with her because she has a great and accurate experiment. But the reason why I said it is because it is hard to say if that they control it to be the same and chaotic behavior is actually very sensitive to natural conditions, and not enough data shown. Yes, I think But I think there's a variety of different data, but I think it will be better if she just write down, but not just use a chart to represent. And control water flow rate. I think she can have the more describe about that.
Okay, thank you very much. So for the reviewer, questions for the two.
Okay, so first I have a question for the reporter. So in your presentation, you mentioned about the damping period of the water droplets. So what exactly is it? The damping period in your presentation? Never mind. So let's go to the next question. Please turn to page 5. What is, you mentioned about the R here, so can you define what R is? Because it may be around here or the here.
Because it's my draw. If in a real video, the R is very clear. So can see the R in the real video.
So do you infer that the R, 2R equals the diameter of the dripping faucet? Is that it?
R, no,
No. So
but it have a relation with the diameter.
it has a relationship with the diameter.
Yes.
Okay. Let's move on to page 6. So what is X here? Do you mean that X is a length of this?
Oh yes.
So what is it? What does this time?
Maybe it have a sound more length. Maybe if the length is above below length. Yes.
So when does it start? When do we draw this line?
Yes.
Okay.
Where's the length?
Can we go to page 7? And so what is the vibration time in this case?
Vibration time is like this video. Like can see it when a droplet fall, the droplet can have the vibration. So it's a vibration like a spring.
So when the vibration starts, we start recording. Then the vibration stops, we stop recording. Is that it?
When droplet fall, the vibration stops.
So we start the recording from then, and stops when the droplet stops vibrating, right?
No, but the droplet fall, the vibration stops.
Okay. So can we go to 13 for number of questions? What does this NA come from? What's the source of this force?
This meaning is this is the fault the vibration. Like because when droplet fall have this vibration, and if the vibration is here, we say it's down. The vibration is here, we say it's up.
Very
Thank
good
you.
discussion. Thank you.